This is a special session. This is heritage lecture. This will present the geotechnical characteristics of Korean heritage structures, including palaces and castles. Recent research for preserving the historic structure and the case of restoring ancient bridge in Gyeongju will be introduced. The presenter of this heritage lecture is Professor Yeon-Soo Jang. Let me give you a brief beta for him. He got bachelor's and master's degree from the Seoul National University in Korea, and he got his PhD from the University of California, Berkeley. He is serving as a professor from 1993 as a professor at Dongguk University, and he was the past, actually the 14th president of the KGS. Welcome, Professor Jang.
Thank you, Chairman, for kind introduction. Distinguished guests, ladies and gentlemen, it is my great privilege to introduce geotechnical characteristics through the heritage lecture. Before going the heritage lecture, I was asked from the preparation committee of ICSMG to give an introduction about the Korean Geotechnical Society. I assume that you would be pleased to hearing about the status of Korean Geotechnical Society. Korean Geotechnical Society is founded in 1984. First president was Professor Byung-Jae Lim in Korea University. Our society was flourished, and third president, Professor Sang-Kyu Kim, was a president. He also was a vice president of Asia, ISSMG, from 1997 to 2001. We have joined ISSMG in 1989, and currently we started KGS member 130 in 1984, and currently 2017 about 1,200 is a member, and among these 2660 is the life members. Here are the lists of our past present. You can see 3 and 4 here is the Professor Sang-Kyu Kim. He has a presidency for 4 years, but every 2 years we changed our president. Particularly here, the Professor Hong-taek Kim. He is the next president of Korean Society of Civil Engineering, and we at this period we have started to make an effort to invite this conference. Current president is Sang-Sam Jung at Yonsei University. He's also chair of ATC 18 Mega Foundation and co-chair of TC 12 Deep Foundations. We have 16 technical committees. Here is the list from foundation number 1 to 16 to unsaturated soils. Some TCs like Coastal Harbor Geotechnics, it is not in the ISSMG TC, but it is made from the according to the demands of a Korean industry sector. And we have publications, both Korean and English. English version is the open access journal from publisher is the Springer. And we also have a society magazine, Geotechnical Magazine. We call in Korean Jiban. We give KGS award from 2011. First awardee was Professor Sang-Chul Bang and Dr. Sujan Nakasi. This morning I saw Dr. Sujan Nakasi has participated in this conference. And you can see many familiar faces and names in the lists. 2017, this year, Professor Carlos Santamaria is the recipient. International activities of KGS, from 2011, we have several international symposiums held, and in the 2016, we had the IS Code, that's 11th International Symposium for Cold Region Development. And we have another Vice President of ISSMG for Asia, starting from this year to 2021. Is Professor Un Chul Shin. He's currently affiliated at Incheon National University. Final slide is I want to show the registration numbers of this conference up to now. So as of September the 2nd, the total number of participants was 1727 from 80 countries. Among these, domestically, we had 375. This morning, I heard on-site registration number, that is 25, so exactly 400 members is from the domestic, and 27 is added to 17 is 1,033. So about 1,000 member is registered from the overload. Thank you very much for your active participation. And we also had the IYGC, that's a Young Geotech Engineers Conference. Totally 108 participants came from 53 countries. This conference was also a great success. Thank you. Now is the time for the heritage lecture. The topic is the geotechnical issues and the preservation of a Korean heritage site. Originally, I was intended to show the beauties of Korean heritage structures as well as geotechnical characteristics hidden in the structure, but I recognized that the time is too limited to show all about this, so I decided to concentrate, talk about the geotechnical characteristics of heritage structures. So Korea has 12 properties of UNESCO World Heritage. That is a palace and shrine built in Joseon Dynasty, and a fortress and castle from ancient period from AD 500. And locally, Gyeongju and Baekje historic site is also in the heritage lists. These are the table which shows the World Heritage lists and the registered year. You can see from 1995 to 2015, we had 12 heritage structure. So some Seokgram Grotto and the Bulguksa Temple and the Haeinsa Temple. This is the Buddhism legacies. And the Hwasong Fortress is a castle. And the Changdeokgung Palace, it is the palace. Also, in number 7 is the Gyeongju Heritage Site. This structure is a Cheomseongdae, and we had also big tombs. So there's a big royal tombs in Shilla period. This one is the Jeju Island, which is very interesting from the geological sense. So what I talk about in this presentation is geotechnical characteristics of historic heritage architectures, particularly foundations, walls of the heritages. Recent research of heritage structures related to earthquake and the case of restoring an ancient bridge in Gyeongju would be talked. And if I had a time, geological significance of Jeju volcanic island would be talked. First is a palace in Joseon Dynasty. Joseon had 5 palaces in Seoul. That is the Gyeongbokgung, which was the main palace built in 1395. And Changdeokgung, which is a secondary palace built in 1405, but it became a main palace after 1592. In 1592, we had a big war with the neighboring countries. And Changgyeonggung and Gyeonggigung and the Deoksugung is the other palace. So the picture you shown here is the Gyeongbokgung Palace, Gunjeongjeon. It's a wooden two-story buildings founded on the stone stylobite, which the type of stone is granite. Let me show the layout of Gyeongbokgung. So Gyeongbokgung, we had a gate here, and it is laid in the straight form from the south to the north. So Gunjeongjeon is located here. This part is the official area for the king. And in the middle area is the private area for royal families. And the backside is the garden for the royal family. So here is an example halls. That's the Gyeonghaeru Pavilion, which is a very beautiful structure built in Joseon Dynasty. This is the night view of Gyeongbokgung. You can find pretty good scenery. Next one is the Changdeokgung Palace. It was built, as I told you, it was built in 1405. Contrary to the Gyeongbokgung Palace, Changdeokgung Palace, the gate is on the left side, and you go in this direction. Here is Injeongjeon, similar structure like a Gunjeongjeon in Gyeongbokgung, and this side is royal family, private side, and the B1 is pretty famous in Korean ancient architecture. It is located behind this area. So, as I told you, it is layout not straight form. It is conformed to the geomorphology of this area. This is Injeongjeon. It is also a two-story building on a stone stylobite. Let me show you two beautiful pictures, which looks like a beautiful garden, but actually it is a gravity retaining wall that resists the horizontal slope pressure from the slope. So this is the sections which describes both structures. So when the Joseon people, they built this kind of structure when they had the lower hills in the palaces. So they put the plants, and then the soil can drain the rainwater very freely under these structures. What is the foundation of a palace stylobite? So this is Gunjeongjeon again. It has a very wide area in front of the hall. There is a walde. And here are the sections you can see. This is the palace. The foundation of a palace we call is a stylobite. Korean name is a gidan. And in front, there is a walde. This front area is always oriented to the south or the east to have better sunshine during the daytimes. And we had foundations which is a cornerstone type foundations many times. So these are the sections of foundation I show. So people dig into the bottom area, which is composed of hard soil or base rock, and then they put many coarse liplap, crushed stone, and then they put lime mixed soil. Lime in Korean is ganghwae, which is a quicklime type lime. And they put this lime mixed soil at the junction of this compacted layer to increase the cohesion between the layers. So up to the original soil, they put the layers in the same form, and over this in the stylobite area, they put stone with the compacted soil to the cornerstone. So this is example cornerstone in the palace area. You can see the rows of cornerstone with the pedestals. This one was, I took the photo in the Jongno, between the Changdeokgung and Gyeongbokgung Palace. You can, this one is the foundation for the high-ranked people. And this one is the foundation for the public agency houses. So nowadays, the City Hall of Seoul requires the preservation of excavated sites of Joseon Dynasty to licensing the construction of the buildings. I moved to the fortresses and castles from ancient Korea. So from the Three Kingdoms period, we had the Three Kingdoms in BC 57 to AD 668. Both earthen and stone fortresses were constructed. So I have three example pictures. This one, this is the Mongcheon earthen fortresses. You can see this tree planted area. This is the earthen fortresses, and in front a big pond is located. This pond is moat, which means which is used for preventing the enemies approaching to the fortress wall. And this is Naman Sansang, which is actually made from Shilla period and then survived in the recent days. And this is Suwon Hwasong Fortress, which is built in 1796 to 1798, just 3 years. Let me talk about more about the earthen fortresses. If you are going to the Hansong Baekje Museum in 88 Olympic Park, which is about 15 minutes car driving distances to the east, then you can, inside of this museum, you can find out this big structure. This one is a prototype structure, which is deliberately copied from the excavation of Pungnap Dosung. At the Pungnap Dosung in 2011, they excavated and using the soft clothes with the resin paste, they reproduced the area and in this part. What they use to make this large embankment is that it's a panchuk method. Panchuk method is they make this kind of wooden box and then compact the soil. Are you curious about the sections? I bring here the sections, detailed sections. You can recognize the layers they compacted, and also the straight lines. That is probably the boundaries the wooden boxes had made. Okay, how about the stone castle walls? In our country, the types of a castle wall is made by dry masonry work, which means that we are using these walls without using the mortars, lime mortars. So the height of this castle wall is between 4 meters to 6 meters. And since we do not use the mortars, we had big, huge backfields in the backside. So in contact with the wall, we used the riprap, it's a crushed stone, and then upon it, we have an embankment with soil. There's a lime mixed soil to increase the cohesion. Wet masonry work, that is chalsak in Korean name. It is often used in the European castles. I bring here an example. I took this one when I make a journey to Croatia recently. So this is Gled Dubrovnik. You can see very thin walls in this castle. And this one is the sections, by looking this car height, this one is much over the 10 meters. So they have to use the mortars to make a wall. So the type is quite different in Koreans. Here is the example of our castle wall inside of the fortress. It's a Suwon Hwasong. Now I move to the locals. So this one is South Korea, and the southeastern part of Korea. There is a place, Gyeongju Historic Site. It is registered as UNESCO Heritage in 2000. It was an ancient capital city of Shilla from 57 to 80, 935, about millennium, long kingdom. At the 8th century, at the peak of Gyeongju, they had 0.9 million residents, which is almost equivalent to the populations in the Istanbul, that's Constantinople at the time. And this city has many historical monuments scattered in all around the area. So this is Namsan, located in Gyeongju area. This red dot shows various structures, including Chamseongdae and Hwangnongsa Temple, etc. Let me show you the Chamseongdae first. Chamseongdae. It is a stargazing platform constructed at ancient city of Gyeongju during Shilla period. This is the oldest astronomical observatory over 1,300 years. You can see the tiny structure here, and at the back side, this is the Wolsang, which is the capital city of Shilla dynasty. It's also the earthen fortresses constructed at the time. This is the dimension of the Chamseongdae. So it has a height of 917 meters, and width at the top is 285, and then low is 493. Actually, this one is tilted about 3 degrees, and then this inclination seems to be increased as the time goes. And this is the inside of Chamseongdae. So levels are still low side of this structure. This one is probably put when this structure is constructed. I took the picture of Chamseongdae January this year. So this one is looking the south side. So the direction where the windows are located is south side. I can turn to the north side. I think you can recognize the big seam cracks, and this one is a little bit concaved. So this one is settled about 111 millimeter in the north direction compared to the south direction. So let me introduce about the efforts by the team of KAIST. Actually, this is the team of Professor Kim Dong-soo, who is the General Secretary of this conference. They did a non-invasive size survey. It's a linear offset seismic test and the 3D DC resistivity survey. And they show this kind of pictures. And the number 4 is the northeast zone, north to northeast zone. They found a very anomalous zone. And they said that remarkable differences of stiffness and the resistivity were detected between the north and the south of Chamseongdae. So the differential settlement possibly came from this reason. They also did centrifuge tests. This centrifuge test is in the KAIST. And this is the box. Inside the box, they had an option of a shaking table, so they can model the earthquake conditions while rotating this centrifuge box. They had a Chamseongdae model in 2 forms. The first law is the exact same model as the Chamseongdae, prototype Chamseongdae. So at the 9th layer, they had a stone reinforcement, and at the top, they had a square reinforcement. Also, they put a flat stone planes, which is used for the desks when the people looking above the sky. So this is the model in the centrifuge box. And this one is made without reinforcing stones. And what they found out after the test, This original form was resisting very well, but the models without having the stone reinforcement was damaged a lot. And they transferred the settlement if the prototype was got the same forces from the earthquake. They said that it would move 21 millimeter for the first model and 55 millimeter for the second model. They used the earthquake of return period 500 years is equivalent of 0.11 G in 15-second duration. We had actual real earthquake about a year ago, exactly September 14, 216. The earthquake was occurred in a low. Its scale is 5.4 and 5.8. That's about approximately equivalent to 0.12 and 0.14 G in Gyeongju. This one is the people is investigating the damages from the earthquake after the earthquake is finished, and they found that Chamsangdae was actually tilted 2 centimeters. Surprisingly, it's quite near to what Professor Dong-Soo Kim modeled in a centrifuge tests. So reinforcement of a heritage structure is necessary in Gyeongju area for possible earthquakes at the scales of 6.2 to 6.4, which might happen in the future in our country. Now, I want to show the restoration work of Waljeongyo Bridge. This is the Gyeongju again. So this is Walsang. I told you that this one was a capital city of unified Shilla about 1,000 years ago. At the south part, there is a river. It's called Namcheon Stream. And at the time, there was 2 bridges. It is thought that the 2 bridges, Waljeongyo and Iljeongyo. And this Waljeongyo Bridge is in construction. It is restoring now. This picture is the status of the bridge in April of 2014. We expect that this bridge will be finished in 2018 next year. So it is the housed bridge, and also they have a house gate at the abutment area. Why they built it in a housed form? They found at the excavation site many pieces of burnt wood and roof tile in the bridge, around the bridge. And this one is the site, foundation site, when the excavation work is going on. From this north direction, 4 piers were located, and this part was buried by thick soils of 1.5 to 0.4. At the number 4 piers at the south side, they found a scour protection work. This is wood latticed form inside this stone is put. So amazing that at the time they think about this kind of structure to endure the forces of stream power. And when they built this bridge, they did a geotechnical survey, and they found that sand layer of 2.0 and 2.8 thick, and the M value is 25. And the gravel layer is 3 to 5 meters thick. So this one, you think that it is a pretty good condition for construction of the bridge. And this is the abutment area found when the excavation was going on. This one is drawn again in this form, in a graphical form. You can find out many dots here, actually the dots in front. This one is a stone reinforcement, like a reinforcement, with the reinforcement structure in recent years. This stone reinforcement is exactly reproduced when this structure is constructed, is that enough for enduring the backfield forces? It was not. So KICT is a Korean Institute of Construction Technology. They had a nice exhibition box in the hall, behind the hall. They suggest that the reinforcement of 6 to 7 layers of geogrid in this apartment. Now I bring here the video clips of the area. So this is the bridges building now. And this part is the Ulsan fortress. It's a Walsung fortress. You can find out that this part is exploring now. What is surprising is that they found the skeletons of 2 human bodies excavated at the bottom of southwest wall. So this is the wall, exactly the wall. This January 2017, it's, you can find out the 2 people. We presume that it is buried in the 1500 years before as the living sacrifices of wall construction. They, in a superstition, they believe that this earth wall would be go forever if living sacrifice is given to the foundation of the wall. Is that really help for survive this wall in these days? Final topic is the Jeju volcanic island and lava tunnel. It is a volcano. It's a hotspot type volcano. It is not located in between the tectonic plates. It is composed by main summit and 368 parasitic cones and the lava tunnel. So 90% of this land is covered with basalt. So you can see the scenery. The Jeju Island is located at the southern part of Korea, and in the Jeju Island, the northeastern part, there is a lava tube system. It's a Gamunorum lava tube system. It has many caves. It is made at 300,000 and 100,000 years ago. This is the picture, so you can see the parts of lava tube. And in some places, there is a huge lake inside of it, so you should use a boat to hang around this area. Even this is a lava tube system, you can still find out speleothems, which is made from the calcium carbonate sands at the ground surface, which is infiltrated into this lava tube. So you can find out a lot of this thing. Finally, I show you the video which shows the geological shapes of Jeju Island. This is a summit, which is a Baeknokdam Lake, which is most of the time is dry, but when rainfall is coming, then it makes a water table. So this is one parasitic volcano, Gamunorum. So inlet of Gamunorum lava tube, speleothems they made, another form. And the waterfalls, and columnar joint. Columnar joint is exists in many areas in this island. Some details of columnar joint. And a parasitic volcanic form is a Seongsan Ilchul summit. I think I almost spent allotted time, so I skip this concluding remarks. And thank you very much for your kind attention.